Good morning. This morning we are going to learn one of the applications of polynomial equations, and I would like to take this example to help us understand how polynomials is being applied in a real world situation. So let's look at this example. It says that a box is formed by cutting squares of integer length x centimeters from the corners of a piece of cardboard that measures 30 centimeters by 40 centimeters as shown below. So this is the cardboard that measures 40 by 30. We want to cut these corners so that we can form a box. So at the end of the day, the box is going to look something like this after we folded the edges, so something like that. All right, not the best artwork, but at least you can visualize what it's going to look like. So once we have the length of 40 centimeters, if we cut off a length of x on this side and cut off another length of x, so we are going to be left with, so let me put it here, we have 40 centimeters, we cut off x centimeters, so that's going to be a minus, then we cut off another x centimeters. So we are going to end up with 40 minus 2x on this side. So from here to here, it's going to be 40 minus 2x, all right? Then on this side, which is 30 centimeters, we cut off x centimeters, we cut off x, so we are going to be left with 30 minus 2x, right? So that's what we're going to have. So our new length and width, we are going to have 40 minus 2x, and we are going to have 30 minus 2x. So now the question becomes, what do you think is going to be the height of this box? If you visualize this, you see that the height of the box is going to be the length of the x, because once I fold this part upwards, that is going to be the height of the box. So the height of the box is going to be length x, the one we will be finding later on. So this is what it's going to look like. Okay, I hope you understand it up to this point. So we had a 40 by 30, we cut off x, we cut off x, so we are going to be left with 40 minus 2x. On that side, we have 30 centimeters, we cut off x centimeters, we cut off x centimeters, so we'll be left with 30 minus 2x. So those measurement becomes the new length and the width of the box, all right, and x becomes the height. Okay, so now the question goes on to say that find an expression for the volume of the box in terms of x and write the expression in the extended form. So what we know from 8th grade or when we were in middle school, we learned that, and even last year when you did geometry, we learned that the volume of a box like this is going to be a rectangular prism, right? It's going to be the length of the base times the width of the base times the height, right? So this is the formula we know already. So the volume of a rectangular prism like this one is the length times the width times the height. So with that, I can plug in the measurement that I know. So the volume is going to be the length, which is going to be 40 minus 2x, the width, which is 30 minus 2x, and times the height, which is x. Okay, but we are told that we have to write the expression in the standard form, right? So what I'm going to do is that I'm going to multiply these numbers. Okay, so I would like to do the first two. So I'm going to multiply these two first. When I'm done, I'll multiply with the x. Okay, so we could do the FOIL method, right, where we multiply them like that, or you can use a box method to multiply. So when I multiply these two, I will end up with 40 times 30 becomes 1,200. 40 times negative 2 becomes negative 80x. Negative 2 x times 30 becomes negative 60x, and negative 2x times negative 2x becomes positive 4x squared. And remember, we have to still multiply by the x. So when I multiply by the x, I end up with 1200x. Now I can combine these like terms, so negative 80, negative 60 becomes negative 140. So I have negative 140x, but because I'm also multiplying by this x, that becomes x squared. And lastly, I have plus 4x. X squared times x becomes x cubed. Now, because we're asked to write the answer in the standard form, so I'm going to say the volume in terms of x will be 4x cubed minus 140x squared plus 1200x. So that becomes the volume in terms of x of this box. Now it goes on to say, after we've solved for that, the B says, what is the value of x if the volume is 3000 and x is a whole number, right? So they want us to find the value of x assuming the volume of this box that we found, assuming the volume of this box is 3000. Okay, what can be contained here is 3000. So this is what we're going to do. So we are going to replace V, which represents the volume, right? So we're going to have 3000 equals 4x cubed minus 140x squared plus 1200x. Okay, so this is going to be the equation we are going to get. Now to solve for x, I'm going to move the number here, the 3000, to the right hand side, just to make this side 0. All right, so to make one side of the equation 0. So I will end up with 4x cubed minus 140x squared plus 1200x minus 3000. Remember, this was positive on the left hand side. So when I move it over, it becomes a negative. Okay, so therefore equal to 0, because now once this is no more, you have equal to 0. So at this point, what I could do is to use any of the methods we've learned in class to solve for x. But before I do that, I'm going to divide. I see that there's a GCF of 4, so I'm going to divide everything by 4 just to make the numbers smaller. All right, so when I divide everything by 4, I end up with x cubed minus 35x squared plus 300x minus 750. So all I did was that I divided all these terms by 4 to get that. Okay, so here I would like to use the easier method. So I'm going to put this in the calculator and graph, okay, to find the possible values of x. But take note, we are told that x should be a whole number. All right, so let's keep that in mind. Okay. So when I put this in the calculator, I'm going to type this in the calculator and graph it. Okay. So when I do that, I end up with a graph that looks like this. Okay. Something like that. This is a cubic graph. We already learned this some time ago. So I'll get a graph that goes like that. A cubic graph with a positive leading coefficient. So something like this. Okay. Now, remember, we are solving for x. So on this graph, the x values are going to be this one here, that, and that. Okay. Now, this value is 23.66. This one here is 6.34. All right. And that value here is 5. So these are the possible x values. Now, among these values, which one is the whole number, as the question says? All right. So which one is the whole number? We can see that this is the whole number. Okay. And this value would even not make sense if x is 23.6. Now, when you go back to the original question, When I cut off 23.6 here, cut off 23. That is not going to be possible. The whole length is 30. So cutting off 23, that is going to be more than 30. So it means that this answer is not even valid. Okay, so this x value is not valid. This one might work, but this one, because the question says we want x to be a whole number, we are not going to go for the 6.34. So therefore, the x value, therefore the value of x is equal to 5 centimeters. And that becomes the correct answer. Alright, so I'll see you in the next video. Thank you for watching and have a good day. Bye bye.